There is a really quick way of doing this question, which I'll talk about right at the end. I'm going to talk about the way that I did it. I didn't think to do it the quick way. So we want to use the digits 1, 2, 3, 4, 6, 7, 8, and 9. Now these, we want to get prime numbers, so it must be that the primes are going to start with 2, 4, 6, and 8, because they can't end in it. So I decided to write down my primes that start with a 2. That's 23 and 29. And then with the 4, we've got 41, 43, 47, 61 and 67, 83 and 89. So those are the ones that we're going to be using somehow. Now, if we take a look at these two, we can see that actually I must use either 2 with 3 and 8 with 9, or 2 with 9 and 8 with 3, because I can't, for example, use 2 with 9 and then 8 with 9. So I could, for example, go with 23 and 89. Notice that when I add up 23 and 89, I'll get the same answer as when I add up 29 and 83, because I've just basically swapped the digits around. And so now I've used the 3, that one's out, and we see a very similar thing going on with 41 and 47, and 61 and 67. So I could go with 41 and then 67. Those would use all the digits. Or I could go on with 47 and 61. In fact, there's 4 different ways we could do this, because there's 2 ways I could have picked them from here, could swap them around, and there's 2 ways from here. So 2 times 2 in total. Anyway, this is an example of 4 primes that satisfy the property, um, but are 2-digit primes where every digit is used except 5, every non-zero digit, I should say. So what is the value of them? Well, I can add up 89 and 41 quite quickly. That's going to be 90 plus 40, 130. And then 23 plus 67 gives me 90. So 130 plus 90 gives us 220. Now for the quick way, this avoids ever having to write down any primes. It doesn't prove that you can do it, which is what I've done, but it proves that if you can do it, then this must be the answer. So we actually use the idea that we have to use 2, 4, 6, and 8 as the tens digit. So if we add these up and times by 10, then that will actually give us the sum of the tens digits in total. And then we clearly then have to add 1, 3, 7, and 9, which will be the units digits. So we just get 200 plus 20 to give 220. Now that is pretty smart. Fair play if you spotted that. So, but what this doesn't actually show is if it's possible, which is what I've managed to show on the left. So you would actually still have to just check that it is possible. But in the context of the SMC, you could quickly do this question using this approach.